Hello students, this is the first video in the 6th unit. The 6th unit we're going to be talking about triangle proofs, and today we're just going to be talking about corresponding parts. As you may remember from previous units, corresponding parts are just parts that are in the same place but different shapes. So we're going to be looking specifically at triangles here, but corresponding parts could be applied to any kind of shape. We have applied it to parallel lines and transversals before. We're also going to be applying it eventually to quadrilaterals and other polygons. Let's take a look at the learning target. For this learning target, we're going to explain the meaning of congruent triangles, so what that actually means, and to name corresponding parts of congruent triangles. So congruent triangles we're going to be talking about, as I said before, and naming their corresponding parts is a really big, important topic in this unit. And again, we're talking about same place but different shape for corresponding. That's a quick definition. I'll give you a better definition a little later. For now, you're going to give me a definition. We're going to be doing this in class as well, but I'm looking for what the definition of the word congruent is. So pause the video for a second and try to figure out what your best definition of congruent is. All right, the definition that I like to use with students is that all of their measures are equal, and as an aside to that, two figures that are identical in shape and size are congruent. If they're identical in shape and size, that means that their shape, for example, if it's two triangles, it's exactly the same, and the size, in other words, the size of the sides and the size of the angles are also the same. So all of their measures are equal. Let's take a look at the term corresponding parts, because the last time we talked about corresponding parts, as I said, corresponding parts were in parallel lines and transversals. As a quick reminder, you may remember that if there are two parallel lines that are cut by a transversal, the two angles that are in the same place but in different shapes, we refer to those angles as corresponding same place but different shape. Another thing that we know about these two corresponding angles is that they are congruent. So that's where you've heard the term corresponding before in geometry. Now let's introduce the idea of corresponding parts. Corresponding parts are two parts, either sides or angles in two shapes, that are in the same place. Now we talk about the same place, but it's not always exactly the same spot on the paper. It's just in the same place on the shape. For example, in the triangle above, or the two triangles above, I should say, triangle ABC and triangle DEF, here are the corresponding parts. Let's take a look at a couple of those parts. Angle A and angle D. So here's angle A, and one thing that you should notice about angle A, it's got these two arcs with it, and then angle D also has those two arcs with it. Notice that these two angles are in the same spot, just in different shapes, right? This is you could say it's the top of the triangle here, and angle D is what happens when you take this triangle and spin it around a little bit and reflect it, but it's still in that same place, but it's in a different shape. So A and D are corresponding. We can also say that B and E are corresponding because the B is around here and the E is around here. See, they're in the same place, but they're just in different shapes. And similarly, we can talk about angles C and F as being corresponding because C is the smallest angle here. It's on like the point of this triangle, and F is the same thing. It's that smallest angle on the point of the triangle. They're not exactly in the same exact place on the paper, but for each of the triangles, they're in that corresponding space, right? C corresponds to F. And then we can also do the same thing for sides. For example, we have AB, that side from here to here. Looks like it's the shortest side of the triangle, and that side corresponds to side DE, which is of course also the shortest side of this triangle. You can notice that they have the same hash mark here, so these particular corresponding sides are congruent. They don't always have to be congruent. Corresponding just means same place, different shape. And then for BC and EF, you can see that BC is the bottom of this triangle here, and EF isn't the bottom of this triangle, but it's in the same place in this triangle. It's in the place that's sort of next to that yellow side, right? And then last but not least, we got AC and we have DF. AC is the side that's over here. It's between the angle with the 3 hash marks and the 2 hash marks. And then DF is this side here. Again, it's between the 2 hash marks and the 3 hash marks here. So we can identify corresponding sides and also corresponding angles based on where they are in the triangle. Now, in this particular case, you should notice that the corresponding parts were congruent. For example, angle A and angle D both have those two curves on them, the two arcs. That means that they are congruent to each other. But like I said before, corresponding parts don't have to be congruent. Here's an example. In these triangles, this is triangle GHI and this is triangle JKL. They're both right triangles, so we can sort of identify where the corresponding parts are without necessarily thinking that they're congruent. For example, angle G and angle J. Here's G and here's J. They're both the right angles, and they're both in the same place, just different shapes. Same thing over here. When we're talking about H and K, here's H and here's K. They're in like the smallest portion, the smallest angle of the triangle. They're on that right-hand side, and they both are corresponding because they're in the same place. And last but not least, I and L, I'll use yellow for these, I and L are here and here respectively. They're just in the same place but different shapes. I don't want to belabor that point too much. Now let's take a look at the corresponding sides. This first part says that GH and JK are corresponding, so here's GH and here's JK. Notice they're both on the bottom of the triangle. They don't always have to be both on the same side of the triangle as we saw before. And also you can see that they're not the same measurement, but they are in the same corresponding place in the shape. It's touching the right angle and it's touching that smallest angle. Same thing, touching the right angle, touching that smallest angle. So they're corresponding. Same thing goes for HI and JK. HI and JK are both the hypotenuse for their respective triangles. That doesn't mean that they're the same size. Far from it, doesn't have to be. They're just in the same place for those different shapes. And then GI and JL have that same thing. GI and JL are in the same place, different shapes. They are corresponding. Okay, great. So now that we talked about corresponding parts, let's talk about how we can tell whether corresponding parts make triangles congruent or not. Before we do that, let's remind everybody of what we just talked about maybe 4 minutes ago. Remember, congruent means two figures that are identical in shape and size. All of their measures are equal. That's right, all of their measures are equal. So when you think about a triangle, there's really 6 measures that you can figure out for a triangle. There's 3 measures for their angles and 3 measures for their sides. So that means if I were to try to talk about congruent and non-congruent triangles, a pair of congruent triangles would really have 3 sides that are congruent and 3 angles that are congruent. Let's take a look down here at triangles ABC and XYZ. You can clearly see that angle A and angle X are congruent to each other because they have that one arc. Angles B and Y are also congruent to each other because they have those 2 hash marks, or 2 arc marks, I should say. And angle C and angle Z are congruent to each other because they have the 3 arcs, right? So these 3 angles, or I should say the 3 pairs of angles, angles A and X, angles B and Y, and angles C and Z are all congruent to each other. And also we can say that the sides are, the corresponding sides are congruent. For example, AB, which is this side here, has 3 hash marks. And XY, which is this side here, has also 3 hash marks. So these corresponding parts are congruent to each other. That's where this little symbol comes from. That symbol means congruent. And then BC, which is this side here, has 1 hash mark. Its corresponding side, YZ, also has 1 hash mark. So it is, or those 2 angles, sides, I should say, are congruent to each other. BC and YC are congruent. And then last but not least, AC has 2 hash marks, and XZ has 2 hash marks. So these 2 corresponding parts also happen to be congruent. So AC and XZ are congruent to each other. So now that we have that all 3 pairs of angles and all 3 pairs of sides are congruent, then we can say definitively that triangle ABC is congruent to triangle XYZ. On this other example, we can see that some of their corresponding parts are going to be congruent, but we don't know all of them. So let's take a quick look. We know that angle A, this angle, has 1 arc. We also know that angle D has 1 arc. So that means that angles A and D, the corresponding angles here, happen to be congruent. Similarly, we know that angle B is 2 hash marks, or 2 arc marks, I should say, and angle E has 2 arc marks as well. So that means angle B and angle E are congruent. However, we don't have any hash marks for side AB. We don't have any marks for AC, we don't have any marks for BC, so we do know some of the parts are congruent, but we don't have all the information to say that all 6 of the corresponding parts are going to be congruent. So since we don't have that information, we have to make the conclusion that triangle ABC is not necessarily congruent to triangle DEF. You're only able to say that 2 shapes are congruent if you're able to say that all 6 of their corresponding parts are congruent. More on that later. There are some shortcuts that we'll be learning about later on in the unit, but as of right now, you need all 6. All right. The check for understanding is something that you're going to take a look at in class. You're going to be identifying corresponding parts for these 2 figures, but for right now, that's all we got. So thank you for watching this video, the first video in the 6th unit on proofs. Good luck studying.